So let's talk a little bit about, more generally about dimensional analysis. Where this all comes from is the idea of a reference frame. Your reference frame provides the context for quantifying anything in the real world. So we come up with all these numbers. If these numbers are going to be useful, we all have to agree on what those numbers mean, and the fundamentals of that is understanding a reference frame. The reference frame has components that are described by some collection of dimensions. So these things I keep calling dimensions are a way to break down a reference frame so that we know how an individual element of a reference frame is going to be quantified. Measured variables then have dimensions that pick off some bit of a reference frame to say, I know something about this part of the reference frame. I know something about a value that represents the quantity of something going on in that reference frame. We've talked a little bit about some fundamental dimensions. Let's review those. There are those related to space-time. So we have length as the fundamental dimension for space and time as a fundamental dimension for time. And finally, there are those that get you into mass and energy because you need to move a mass before you can talk about energy. So we have this fundamental dimension or property of matter called mass. And also we have a fundamental property called temperature, which tells you something about the thermal energy associated with a mass. Now, if you really dig into dimensional analysis, you might find that temperature is actually a derived dimension and that you can break it down more into characteristics of an energy density. But for the purposes of this class, we're going to stick to temperature as being a fundamental dimension. That is the capital Greek letter theta, by the way. So we typically use the Greek, because we use T for time, we use the Greek letter theta for temperature in terms of dimensionality. So these are the four fundamental dimensions that we're primarily going to be interested in this class. Some rules for formatting dimensions, and this is important because this is one of those things where it's grounds for losing points on assignments. I really want you to get this right. When I ask for dimensions, please be sure to give me dimensions and not units. When I say dimensions, I don't mean units. Also, please format them correctly. So when you're making dimensions, it's really important not to get them confused with variables or other mathematical entities in what you're writing. So you want to do things that keep them separate. Use capital letters with non-italicized fonts. That's because variables are typically italicized, so dimensions should not be. Always put dimensions in square brackets. That keeps them separate from variables. So that, again, it helps you not get confused between a dimension and a variable. That's pretty important for dimensions like capital L, since L is the same abbreviation we typically use for liters as units. So in order to make sure you're not getting that L for length confused with L for liters, you put it in square brackets, you immediately know the difference. So those square brackets are extremely important. Finally, it's best to use negative exponents rather than fractions. It's not technically incorrect to use fractions, but it can be ambiguous. For example, let's talk about a mass flux. So I said a flux is anything per unit area per time. So in this case, instead of a volume, which would be a length cubed, we're talking about a mass flux, or an m per L squared per time. And I've used negative exponents here in contrast to another way of maybe separating a fraction. Why do we do this? Well, it's a less ambiguous order of operations. If you are looking at the m/L squared t, that could be interpreted in a couple of different ways depending on where you thought the order of operations should go. And these are very different dimensions from each other, these two definitions. If you really want a mass flux, mass per area per time, it's the way to write that with exponents is very hard to get confused because those negative exponents are specific to each term. And you have no question about what's in the numerator and the denominator when you're talking about dimensions using these exponents. So I would prefer that you use an exponential form with positive and negative exponents denoting what's in the numerator and denominator when talking about dimensions for this class.